Hey everyone, Matt here, and we're going to talk about multiplying rational expressions. What's a rational expression? That's just a fancy way of saying fractions. Yes, we're going to deal with fractions. Now, multiplying and dividing fractions, it's a little easier than adding and subtracting them. So I kind of go out of order, and we're going to learn how to multiply them first. Okay, so let's go and talk about things that we learned about multiplying fractions back in probably elementary school somewhere. And so right here, if you take a look at two fractions you need to multiply, you just multiply the top over multiply the bottom. That's all you do. Pretty simple, okay? Now, in this situation, there's a couple things you can do. You can multiply and get 15 over 240 or whatever that is, but anything on top can reduce to anything on bottom when you're multiplying. So they can cross, they can, whatever you want to do, you can cancel anything out, okay? Now remember, don't do this when it's fraction equal. That's proportions, that's very different, okay? That's when we cross multiply and do all that, when there's an equal sign between the fractions. But here it's multiply. So what I can do is this. The 5 and the 20 as the corners, 5 goes into 5 once, 5 goes into 20 4 times. Look at the 3 and the 12. 3 will go in the 3 once, 3 will go in the 12 4 times. Now, once you've done all the cross canceling and reducing, and you can do it in the same fraction, just anything on top to anything on bottom, once you're done, multiply through, and I get 1 over 16 for my answer, okay? And so that's stuff that you probably have already learned. Now we do them with letters, okay? So I have x to the 5, y to the 6. Now what I could do is multiply it and go x to the 5, y 6 over y, well, maybe I should write the x first, right? x3, y2, and then I just do like what we did in the earlier section when we talked about dividing, dividing with exponents. You can follow that. But there's actually a quicker way to do this. It's a little messier, so this way is fine. You can do it this way, but it's a little quicker also if you look at, again, reducing anything on top to anything on bottom. I have 5 x's on top and I have 3 on bottom. That cancels out and I'm left with x squared on top. I have 2 y's on the bottom. I have 6 on top. All my 2's will cancel out and I'm going to be left with 4 on top. And my answer will be x squared y to the 4th. So there's one way you can do that, okay? Now again, you're allowed to do that with anything that multiplies. Here's one part that's the confusion. Watch this. I'm going to write x plus 4 over x minus 2. Question, am I allowed to cancel out those x's? No, I am not. That would be wrong. You would get that wrong if you did it. Now the question is why? So in what situations, if I had this, watch this, 3x over 2x, am I allowed to cancel out the x's? Yes, I am. So why am I allowed to do it here, and why am I not allowed to do it here? The answer is these plus and minus signs. I want you to see those plus and minuses and think about it like a glue that just holds them together and won't let them break down. You can't cancel if it's attached to a plus or a minus. Now the real reason is you can only cancel out what we call factors. Factors are things that are being multiplied. This is 3 and x being multiplied together. This is 4 and x being added together, okay? If they're being added or subtracted, you can't cancel them. You can only cancel if they're being multiplied. So once you see a plus or a minus, you're done. You can't cancel any of them out. Can I reduce the 4 and the 2? Nope, because they are attached to the plus and minus. Now that's going to come into play in the next ones we're going to do. So let me erase the board and let's look at a few more. Okay, if you can do the problems up on the board right now, you're going to be able to do anything that involves multiplying fractions here in Algebra 1, okay? So now let's take a look at this. Remember when I said you can't cancel the x's right here? That's still true. However, we said that we can do factors. Remember, factors are things that are being multiplied. Look here on this one. Do you see how they're in parentheses? This right here is a factor, the entire parenthesis, because that's a parenthesis times a parenthesis. So right now I have 2 factors. There's a factor here, there's a factor here. The entire numerator is a factor, and the entire denominator is a factor. So I really have 6 factors here. So these are all things that are being multiplied by each other. So what I can do here, and you are allowed to do this, so I don't want you to get this mixed up with my other example, I'm allowed to take an entire parenthesis or an entire numerator and treat that as it's a factor. So this x plus 2 in the parenthesis can cross out with the entire x plus 2. I can't cross out the x, and I can't cross out the 2, but I can cross out the entire x plus 2. Okay, now here I have an x minus 3, and that can cancel out with that x minus 3. And what's my answer? Whatever's left over, which is x minus 1 over x minus 4. Am I allowed to cancel out the x's? No, I am not, because that's not a factor anymore. That x is not being times. So an entire parenthesis is considered a factor, and you can cancel out entire parentheses. Now, let's look at this last one. This last one can get a little bit messy. So let's go, let's do it. Okay, so now, my first thing is I look at all this, this is super messy, right? So the first thing you want to do is you want to fully factor everything. So what I'm going to do, I look at this one and I say, hey, that's a difference of 2 squares. I did this in the factoring section, so go back if this is confusing to you and look at it. You need to recognize that as x plus 3, x minus 3. I just restated it, so now I'm not looking at that, I just rewrote it as that. Okay, this one right here is a what's the same, what's left over. I can pull out a 4, and what's left over, x minus 3. Now don't look at that anymore, we're only looking at that. How about this one? Well, this is a trinomial square. We did these when we looked about completing a square. This is where we do the quantity squared. But it's actually a little easier if we write them all out. So I'm going to think of this one as the third term positive, which we talked about in factoring. My third term is positive, so my signs are the same. Take the sign in the middle, so it's going to be plus, plus. What multiplies to 16 and adds to 8? That's a 4 and a 4, and if you notice, they're the same. And lastly, this one I'm just going to, oh, and I don't look at this anymore. And now, this one is a third term negative, so my signs are different. What multiplies to 12 and subtracts to a negative 1? Or just subtracts to a 1? Well, it's going to be 4 and 3, okay? And the bigger one, the 4, will get the sign of the negative, so it's a minus 4 and a plus 3. Boom, boom. My friends, this is now the problem. Okay, so if I'm going to just rewrite it now, because you can actually start canceling things out from here. It is a bit messy. So just so you can see it, I'm going to write it here. This is x plus 3, x minus 3, over 4, x minus 3, times x plus 4, x plus 4, over x plus 3, x minus 4. So by me doing all the factoring that we did in that whole factor section, doing all that, I just rewrote the problem there. Now I'm going to look for entire things that I can cross out. Well, I see an x plus 3 here, and I see an x plus 3 there. I see an x minus 3 here, and I see an x minus 3 there. I see an x minus 4, but I don't see an x minus 4 up there. So I'm going to write my answer like this. X plus 4, and I can write it as quantity squared because I have 2 of them. And what's left over on bottom? Just a 4 and an x minus 4. So I'm going to write 4, x minus 4. And that, my friends, is the answer. Now you may ask yourself, should I distribute the 4 and get 4x minus 16? Should I multiply out, the x plus 4 twice? No. We want to always leave them in the fully factored form, meaning in the form where it's showing things are being multiplied. So this would be considered the final answer. Now, the way to get good at these is to do a lot of them. And so I have worksheets. They're on the practice sheets at maxtutorial.com. Go there, and these ones are kind of sequential. So this isn't do A and you know it all. This one you're going to want to do A, and then B gets a little bit harder, and C gets a little bit harder. So do all 3 worksheets, and if you can do all those and watch me go through them with you, you guys are going to be a pro at multiplying. Take care.